Welcome back to our series on probability. This is GordMaths, where mathematical literacy begins. In today's lesson, we will look at random variables. Remember to subscribe to this channel for more interesting lessons. A random variable is any variable which gives a numerical description of the outcome of a random activity. Taking the experiment of flipping 2 coins at a time, then we know that the sample space, as discussed in our previous lessons, is head, 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 tail, tail, head, and then tail, tail. Suppose X is the number of tails obtained from this experiment. Then we will say that X is a random variable which takes up the values X is equal to 0, 1, and 2. This is because in some of the outcomes of the experiment we have 0 tails, where X is representing the number of tails. In some of the outcomes we have 1 tail, and then we have 2 tails in other elements in the sample space. And so we say that X is a random variable whose outcome depends on the outcome of this experiment. There are 2 basic types of random variables. We have the discrete random variables and the continuous random variables. This lesson focuses more on the discrete random variables. A discrete random variable is a random variable which takes on countable number of possible values. So the possible values of a discrete random variable are countable whole numbers. And then if X is a discrete random variable, then the probability mass function of X is, probability mass function is any function which assigns the random variable capital X to a certain real value which we are representing by a small x. So the probability mass function of X is given by probability of a certain real value X is equal to the probability that the random variable capital X is equal to that real value small x, and that should satisfy the following conditions. The first one is that 0 is less than or equal to the probability of xi, which is less than or equal to 1. And this means that any given probability value for the random variable should range from 0 to 1. And then the second one is that the sum of all the probabilities for the real values of the random variable x should be equal to 1. We will take a few examples under discrete random variables. Let X be a discrete random variable with a probability mass function given here, where X is equal to 1, 2, 3, and 4, and 0 otherwise. Find the value of C. Now this means that this probability mass function is for the values of X 1, 2, 3, 4. All other values of X will have a probability of 0. And so, with the idea that the sum of all probabilities for the given values of the random variable X is equal to 1, where in this case X ranges from 1 to 4, then we will say that probability of X equal to 1 plus probability of X equal to 2 plus probability of X equal to 3 plus probability of X equal to 4 should be equal to 1. And then when X is equal to 1, that means we will put 1 in place of X, which will give us C, plus when X is equal to 2, we put it in place of X and we have 2C, plus when X is equal to 3, we will have 3C plus 4C equal to 1. This will give us 10C is equal to 1. And so C is equal to 1 over 10. And now to the second question. We are given a discrete random variable with probability mass function given here, where this PMF is for the values of x 0, 1, 2, and 3. And then the probability is 0 for all other values of x. And so, still with the idea or one of the conditions of a discrete random variable, we know that the sum of all the probability values is equal to 1. The sum of all probabilities for the given values of the discrete random variable should be equal to 1. And so, we have from x is equal to 0 up to 3, which means that probability of x equal to 0, probability of x equal to 1, probability of x equal to 2, and then probability of x equal to 3 should all sum up to 1. And then when x is equal to 0, we put 0 in place of x. And that will give us k 1 minus 0 squared plus k 1 minus 1 squared plus k 1 minus 2 squared plus k 1 minus 3 squared is equal to 1. This will give us k negative 1 squared plus k 0 squared plus k, this is 1, negative 1 squared plus k negative 2 squared is equal to 1. So we sum them. We will have k plus this will give us 0, and then k plus negative 2 squared will give us 4k equal to 1. We add this to have 6k is equal to 1, and then k is equal to 1 over 6. Next, we will look at the expectation of a discrete random variable. The expectation or the mean of a discrete random variable, which is also sometimes called the expected value and denoted by E of x or mu x, is given by expectation of x is equal to the summation of x times probability of x, where x takes up the values 0, 1, 2, and so on, and where probability of x is greater than 0. This is because when probability of x is equal to 0, then the expectation will be 0. So this is x equal to 0 up to infinity. Now the expectation of x has some properties, and a few of them are: if the discrete random variable x is multiplied by a constant, say a, then the expectation of ax is given by a expectation of x. And this simply means that the expectation of the constant a is equal to the constant a. There are proofs to this. And then the second one is that the expectation of ax plus b is also equal to a expectation of x plus b. We will take some examples on discrete random variables which deal with the expectations. A random variable has the probability distribution below, and we want to find the expectation of r, where r is a random variable. Now first, before we apply the discrete expectation formula, we must be sure that this random variable is discrete. And what will let us know that it is a discrete random variable is that the sum of all the probability distributions should be equal to 1. So we first add the values here, and that is equal to 1. When it is equal to 1, then we are sure that this is a discrete random variable because it was not stated in the question. Now the expectation of a discrete random variable, expectation of R, is equal to the summation of R times the probability of R, where in this case the R values are 1, 5, and then 6. So the expectation of R is equal to, where R is equal to 1, then we will have 1 times its corresponding probability, 2/3, plus 5, its corresponding probability is 1/4, plus 6, its corresponding probability is 1/12. So we sum up this one to get the expectation. This is 2/3 plus 5/4 plus this cancels to give us 1/2. So we can find the LCM to be 12, and then this is 8 plus 15 plus 6, and that will give us 29/12. This is the expectation of the random variable R. Now to the second question. 2 coins are tossed. Calculate the expectation of X, where X is the number of heads. So we know that in a toss of 2 coins, our sample space U will be head, 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 tail, tail, head, and then tail, tail. So if X is the number of heads, then it means that X is a discrete random variable. It's a discrete random variable which will take up the values, which takes up the values 0, 1, 2, because X represents the number of heads. We have 2 heads, we have 1 head, and we have 0 heads. So X has only 3 values. And the probability distribution of X is given in the table below. This is X, which has the values 0, 1, and then 2. And then we have the probability that the random variable X takes up the real value X. So where X is equal to 0, the probability is, we check that here, there is only 1 element. So the probability is 1 out of the total, which is 4. Where X is equal to 1, we have 2 different cases. So we have 2/4. And then where X is equal to 2, where there are 2 heads, it's only 1 here. So we have 1/4. Then we sum up this probability. If it is equal to 1, then we are sure that X is a discrete random variable. So now since it is equal to 1, we can find the expectation of X as the summation from X is equal to 0 to 2. X has the values 0, 1, 2 of X times the probability of X, which should be equal to, where X is equal to 0, we have 0 times its corresponding probability, X times its probability, plus where X is equal to 1, we have 1 times its probability, and where X is equal to 2, we have 2 times its probability. So this will give us 0 plus, we have 2/4 plus, this will also give us 2/4. And here we will have 4/4, which is equal to 1. So the expectation of X in this case is 1. We will also look at the variance of a discrete random variable. Now, if x is a discrete random variable with mean mu x, then the variance of x is equal to the expectation of x minus mean of x all squared. We know that variance is the square of deviations from the mean in basic statistics. So this is the square of the deviation of x from the mean of x, and that should be equal to the expectation of x squared minus the expectation of x all squared. We will obtain this when we expand this as expectation of x minus mu of x squared is equal to expectation of, when we expand this, we will have x squared minus 2x mu x plus mu of x squared. And this should be equal to the expectation of x squared minus, since 2 is a constant and mu of x is also a constant, the expectation will only affect the x. So we will have 2 expectation of x mu of x plus, this is also a constant, so the expectation will still remain the same. In our previous properties on expectation, we said that the expectation of a constant is a constant. So this is a constant. When we find the expectation, it still gives us the same constant. And that will give us expectation of x squared minus 2 mu of x squared. This is because expectation of x is the same as mu of x. So this times this will give us squared plus mu of x squared. And that will give us expectation of x squared minus mu of x squared. Negative 2 plus 1 will give us this. And this is equal to expectation of x squared minus expectation of x all squared, because mu of x represents expectation of x, so all squared. That is how we have this formula. Then some properties of the variance of a discrete random variable x are: the variance of a constant is 0. And then when we have a constant multiplying our random variable x, then the variance is equal to the square of the constant times the variance of x. And then it follows that if we have the variance of a constant m plus another constant n times x, then this will also give us m squared times the variance of x, because the variance of this constant is going to be 0. So we will only be left with the variance of nx, which is m squared times the variance of x. We will take questions that involve the variance of a random variable. The discrete random variable x has a probability mass function given by, this is the probability mass function of x, where for the values of x equal to 1, 2, and 3, we have kx as the probability distribution of x. And where x is equal to 4 and 5, k in bracket x minus 3 is the probability distribution of x. And for all other values of x, the probability is 0. K is a constant, and we want to find the value of k. Now, from the introduction, we have learned that for discrete random variables, the sum of all the probabilities of a discrete random variable x is equal to a real variable x is equal to 1, where in this case x is equal to 1 up to 5. So we sum all the probabilities from x equal to 1 up to x equal to 5, and that should give us 1. Now, in summing the probabilities, where x is equal to 1, the probability distribution is k times 1, which will give us k, plus Where x is equal to 2, k times 2, that gives us 2k. Where x is equal to 3, we have 3k plus where x is equal to 4, there is a different probability distribution. So we put 4 here, and that gives us k in bracket 4 minus 3 plus k in bracket 5 minus 3. All this should sum up to 1. So this gives us 6k plus, we have k plus 2k is equal to 1. That gives us 9k is equal to 1, which implies that our k is equal to 1 over 9. And so the probability distribution of this random variable will be represented in a table as this. That is to enable us find our expectation. We have our random, we have x here, then probability that the random variable is equal to x, where x takes up the values 1, 2, 3, 4, and then 5. And we also know that the probability mass function of x is now p of x equal to x is given by, we have kx, but now we know k is 1 over 9. So 1 over 9x for the values of x, 1, 2, 3. Then we have 1 over 9. The other one is x minus 3 for the values of x equal to 4, 5. Then the probability is 0 for other values of x. So now for x equal to 1, this is the probability distribution. So we put 1 here, and that gives us 1 over 9. For x equal to 2, we have 2 over 9. For x equal to 3, 3 over 9. For x equal to 4, there is a different probability distribution. So we put 4 here, and we have 1 over 9. X equal to 5 will give us 2 over 9. Now to know that we are correct, we must sum all the probabilities and make sure that it is equal to 1. So we have 1 plus 2, this is 3, 6, 7, 9. And the total will give us 9 over 9, which is equal to 1, which satisfies one of the conditions. Now next, we want to find our expectation. So the expectation of x is equal to the sum of the values of x times the probability of x, where in this case x ranges from 1 up to 5. And the sum is going to be 1 times its corresponding probability, 2 times its corresponding probability, and so on, up to the last one, plus 4, 1 over 9, plus 5, 2 over 9. So we sum all this. This is 1 over 9, plus 4 over 9, plus 9 over 9, plus 4 over 9, plus 10 over 9. And that gives us 5, 14, 18. So we have 28 over 9 as the expectation of x. Then the second one is the expectation of 3x plus 2. Now, one of the properties of expectation is that the expectation of a constant is the constant itself. So this will give us 3 expectation of x, since the expectation of 3 will still give us 3, plus 2. The expectation of 2 is also 2. And so we will have 3 times 28 over 9 plus 2. This will give us 3 goes here, 28 over 3 plus 2. And that should give us 34 over 3. Then, for the last question, we want to find f of 3, where we are told Now, cumulative density function means that the probabilities that are less than or equal to x. So when we say fx, then it is the probability that the random variable x is less than or equal to x. We understand that cumulative means the summation up to. So where it is less than, where the cumulative is up to 3, then we know we are summing the probabilities from 3 downwards. So f of 3 is the same as the probability that x is less than or equal to 3, which will give us, so from 3 downwards, we have 1 over 9 plus 2 over 9 plus 3 over 9. This is 6 over 9, which is equal to 2 over 3. Now we will take another question on this. In this example, a bias die is ruled. Then the discrete random variable x represents the number that shows up. The probability distribution of x is given in the table below. And we are also given that the expectation of x is 3.7. So we want to find the values of m and n. Now we know that one of the conditions that a discrete random variable must satisfy is that all the probabilities of that discrete random variable should sum up to 1. So we will have n plus n plus m plus m plus n plus 0.2 to be equal to 1, which is the sum of all probabilities. Then we will have 2m plus 3n is equal to 0.8. That is 1 minus 0.2. This is one equation. Then we are also given the expectation of x, where we know that expectation of x is the sum of the product of x and its corresponding probabilities. So expectation of x we know is equal to x and its corresponding probability. We sum them all, plus 3m plus 4m plus 5n plus 6, 0.2 is equal to the expectation, which is 3.7. Then when we sum this, we are going to have m, we have 3m and 4m, which will give 7m plus n, 2n and 5n will give 8n. And that should be equal to 3.7 minus 1.2. So we will have 7m plus 8n is equal to, this will give us 2.5. That is our second equation. Then we solve these two equations simultaneously. And you can refer to our lesson on simultaneous equations. And this will give us m is equal to 0.22 and then n is equal to 0.12. You can refer to simultaneous equations for this. Then next, we want to find the expectation of x squared. And the expectation of x squared is equal to x squared times the probability of x. We already know that the expectation of x is equal to x times the probability of x. The expectation of x squared is x squared times the probability of x. And so when we draw this table again using x, then x squared, and then the probability of x. Our x values are 1, 2, 3, 4, 5, and then 6. Then x squared will be 1, 4, 9, 16, 25, 36. Then our probability values, n is 0.12, so 0.12, 0.12, m is 0.22, 0.22, 0.12, and then 0.2. So our expectation of x squared is going to be equal to, we have the sum of x squared, the product of x squared and its probability, then we sum them all. So 1 times 0.12, 4 times 0.12, 9 times 0.22, then 16 times 0.22, 25 times 0.12, plus 36 times 0.2. And when we sum all this, we will have 16.30. That is the expectation of x squared. Now we also want to find the variance of 8 minus 2x. We have already discussed the properties of variance, and we know that the variance of a plus bx should be equal to the variance of a plus the variance of bx, where we know that variance of a constant is 0 and variance of bx is b squared times the variance of x. So the variance of 8 is going to be 0, and then we will have variance of 8 minus 2x to be equal to negative 2 squared times the variance of x. Then next, we find the variance of x, which is the expectation of x squared minus the expectation of x all squared. That will give us the expectation of x squared is 16.30 minus expectation of x is 3.7, so 3.7 all squared. When we do this calculation, we will have the variance of x to be 2.61. Then the variance of 8 minus 2x, which will give us negative 2 squared is 4. So 4 times the variance of x, and that will give us 4 times our 2.61, which will give us 10.44. We will take one trial question for this lesson. Solve these questions on your own and send your answers to us via WhatsApp on the numbers displayed on the screen. In our next lesson, we will look at the binomial and Bernoulli probability distributions. Remember to subscribe for more interesting lessons. This is GordMaths.